Talk about the addition of alcohols, okay, to form hemiacetals and acetals, and we're going to talk about what those mean. So it so happens that if I take, and we're talking about carbonyls, okay. So if I so happens if I take a simple, and this happens with ketones and aldehydes, okay. So if I take simple molecules such as acetone and I add you know ethanol, and you got to do this in acid, okay, I'll get this compound. Okay, this is a molecule I will get. I'll get addition twice to replace the carbonyl oxygen. Okay, so let's go through the mechanism of how this thing happens. So, like we said, anytime you have a ketone, or not a ketone, but a carbonyl, okay, it wants a hydrogen, okay? It wants a hydrogen. So maybe I should draw my acid out, okay? Plus, so the first step of the mechanism, it grabs a hydrogen, okay, and then we get something to look like this. It gets protonation, so we get an oxygen with a plus charge, okay. Now, why does this happen? It makes this carbon slightly a little bit more electrophilic. So therefore, in the next step, or nucleophile ethanol, we know oxygen is a great nucleophile, okay, so it's going to come in, attack, and displace those electrons on the oxygen. And so we get a structure that looks something like this. We get an alcohol, okay, there's our R group, and this now is bonded to an oxygen with a hydrogen. Okay, an oxygen with with three bonds, automatic plus charge. Okay, now in the second step, remember we just formed water. Okay, remember we just formed water, and so what will end up happening is that water is going to use water is going to come in and act as a base and take off one of those hydrogens. Okay, and now we're at a point where the molecule looks something like this. We're in neutral conditions now. Okay, and this is where we call this a hemiacetal. Okay, whenever we have an alcohol that's sitting right adjacent to an oxygen sandwiched in the middle. So this is what we'll call hemiacetal. Now, this doesn't stay in solution for a long time. Okay, so what will end up happening? I'm trying to get some space here. So what will end up happening? Okay, we just reformed acid back here. Okay, we just reformed acid. So H3O plus, okay, that doesn't definitely not 2 pairs. So H3O plus looks something like this. Okay, and the oxygen on the alcohol is very more nucleophilic than the ether oxygen. So it will come in and grab one of those hydrogens, and we reform water back in solution. And so we'll get an oxygen that has 3 bonds. We know that it has to be an automatic plus charge. We still have our R group, and this is what the molecule looks like. Now, what will end up happening? I'll create a carbocation in solution. And so water is a great leaving group, so it could leave now. And so what will end up happening, we have something that looks like this. Okay, we have a plus charge. You form a carbocation in solution. Now, this gives rise to a great opportunity for a second ethanol molecule to come in and attack. So it's going to come in and attack the carbocation. Okay. Now, once that happens, we have something that looks like this. Okay. Oxygen automatic +1 charge. Okay, 3 bonds. So in the last step, remember, we formed water in solution. So water is going to come in and act as a base and take this hydrogen off, and we get our neutral molecule. Okay, and this is where we form the acetal. Okay, this is where we form the acetal. Now the same is true for an aldehyde. So if I take the simplest aromatic aldehyde, in this case, benzaldehyde. So if I take benzaldehyde, okay, and let's say I react this in ethylene glycol in acidic conditions, okay, I have to have my acid. Well, remember we said that the first thing we get is protonation of our carbonyl, Okay, so let's redraw the structure and let's go through the mechanism. So the first step, anytime you throw a carbonyl in acid, we're going to get protonation. So it's going to come in and reform water in solution. Okay, so we get an oxygen that's protonated. We still have our hydrogen. Now this gives rise to a great nucleophile of oxygen to come in. And by the way, this is ethylene glycol, guys. This is ethylene glycol, yeah, protecting group. So one of the lone pairs will act as a nucleophile, attack the carbonyl, and form the alcohol on that bond on that oxygen there. So this becomes, the structure now looks something like this. Alcohol, okay, and this is bonded to an oxygen that has a plus charge, right? Right, oxygen 3 bonds, automatic plus charge. Okay. Now remember, we just formed water in solution in the previous step. So water will come in, act as a base, grab those protons, and form the now what we call the hemiacetal. Okay, we form now the hemiacetal. Okay, so what do you guys think will happen in the next step? What do you guys think will happen in the next step? Okay, the next step is pretty it's pretty simple. Okay, we have our oxygen. We know we're going to create a carbocation in solution. The only way for us to drive, and by the way, this reaction is in equilibrium. Okay, it's in equilibrium all the time. Okay, so to drive this reaction forward, we know OH is a bad leaving group because we need to form a carbocation in solution. So let me redraw the molecule. Okay, let me redraw the molecule. Okay, now we formed we formed water again. We formed water in solution previously. Sorry about the acid. Acid in solution. So this oxygen will come in and take off one of those hydrogens and reform water in solution. Okay, and so we get to a point that looks something like this. We get an oxygen that has 2 hydrogens now, 3 bonds, plus 1 formal charge. We have an OH group. Okay. Now, in the second step, in the next step, water will leave and we're going to create that carbocation. So if you look at this, okay, water will leave and we create that carbocation. I'm trying to get this focus right. Yeah, water will leave, we'll create that carbocation. So we have something that looks like this. We have a carbon that has a plus charge. Okay, now what do you guys think will happen in the next step? Well, the molecule will react with itself. So this oxygen is very nucleophilic, and so it's actually going to come in and bond to the plus charge. Okay, and once that happens, well, what do we get? Well, we have something that looks like this. Okay, we have the remember we have a hydrogen here, so we have something that looks like this. We have, let's say, this bonded to hydrogen here, and we have this oxygen with a plus charge. Okay, because notice we're going to count carbons. Notice we're going to count our bonds. So we have 1, 2, 3, 4. Okay, and we have 5 that make the bond. So if I'm looking at this, we have 1, 2, 3, 4, and these 5, 1 and 5 come together. So if I'm looking at this, we have 1, 2, 3, 4 in between. Okay, so 1 and 5 will come to form the bond, which is right here. And then we have 1, 2, 3, 4 in between. So 1, 2, 3, 4 molecules in between. Okay, so we'll get to a structure that looks like this. Okay, And then simple in the last step, water will come in and act as a base. Okay, and deprotonate. And we get the, yeah, I'm having problems drawing this structure. We'll get this molecule. Okay, so this is the mechanism. So now in the next video, I'm going to talk about the actual some reactions, including these, and how they go about.